Hello, my name is Hsiang-Chun Yeh. I'm from Shekou International School in Shenzhen, and here I present my study, which is called Beyond the Nebula, a photometric and spectroscopic analysis of binary central stars in young planetary nebulae. So what exactly is a planetary nebulae? A PN forms after an intermediate to low mass star dies, and after it dies, it ejects all of elements and its gases outwards, forming these beautiful looking nebulas. Now, if one sees to the right-hand side, the right top image, it is a very typical example of a spherical shaped nebula, and the morphologies of this type of spherical nebula is quite easily explained, which is when the gas are being spread around, it spreads uniformly forming this spherical shape. However, this type of shape only consists of about 20% of total all nebulas, and as a matter of fact, most of the other nebulas have very weird, distinct shapes. For instance, if one sees on the bottom right image, it is a so-called bipolar-shaped planetary nebula, and it's also the exact type of nebula I'll be studying here. The exact mechanism that created this type of shape is actually unknown to this day. However, the most popular theory suggests that this specific type of shape is formed by the presence of binary central stars. Hence, a sample of 11 PNE of similar morphology of the bottom right planetary nebula was collected, and I have performed photometric study to search for their central star periodicities. Okay, so the photometric data were retrieved from the Mass Archive for the TSS telescope, which is a satellite that records photometric variability throughout for the whole sky. And I have downloaded the TSS data of the 11 samples from Mass Archive as TSS cut file, each being 15 × 15 pixels in size, with each pixels of TSS being 21 arcseconds wide. All of the data analysis were performed using the light curve package in Python. Here is the data table of the 11 samples. Now, first I had to manually rule out any possible contaminations within when I extract for light curve, which shows the photometric variability. They were manually inspected, and the pixels with possible contaminations as plotted by the Gaia that's nearby the target has been ruled out, as shown in the image here. And because TSS cut are raw, uncorrected files, I had to perform a median background subtraction and using the regression corrector to perform this stage, so-called a detrending process, which is to rule out any unwanted background noises, essentially, and to produce this usable light curve as shown down here. So these are 3 light curves that showed within the 11 sample that showed clear photometric variability within its center. Now, to perform a more specific analysis, photometry, all of the light curve were converted to parallelogram, which is very similar to what's called a Fourier transform to look for periodicities. And the location of these peaks were fitted using Gaussian curve, and using those periodicity of the peaks, I have folded the light curve to highlight its true features, which is shown here. So as previously mentioned, 3 out of the 11 sample PNE in the sample showed clear photometric variability, and it is worthy to note that FG3 within my sample, I suppose, has been uniquely identified with photometric variability, and it showed very clear, distinct shape as an eclipsing binary. Hence, a spectroscopic study was performed on it of FG3. I have retrieved data from the Spitzer Space Telescope. An infrared spectrum is plotted as below, of 5 to 15 micrometers, and it showed both features of unidentified infrared emission lines as well as crystalline silicate features. Now, the presence of both these features shows that FG3 is actually both a carbon-rich as well as an oxygen-rich PNE, and therefore it will be categorized as a mixed chemistry PNE. And it is suggested by Xia et al. In a 2021 paper that mixed chemistry has strong correlation with binary center, which also supports what has been found from the photometric data. So, in summary, I have investigated a sample of 11 young nested type peony, and 3 out of 11 peony has a sample. In the sample, we discovered to have periodicity in its center from TSS photometry, with FG3's photometric variability being discovered for the first time. And the feature of the infrared spectrum of FG3 suggests that FG3 is a mixed chemistry peony, which is similar to the Hubble 12, as discovered in Chad 2021 paper, which also supports that it has a binary central star. It is also worthy to note that actually the photometry of Hubble 12 was also investigated in the sample. However, there are no obvious signals, but the mixed chemistry from the Shad 2021 paper suggests that it should have binary center. So perhaps for further investigations, photometry spectroscopy from ground-based telescopes should be used to collect data for these samples for higher precisions. Thank you.